Okay, let's continue with the laws of log. This one is a multiplication. Let's go through that. Let's suppose we have an expression that is written in a form of log of m base b equal to x and log of n base b equal to y. Now let's change each one of these ones into the exponential form. Okay, so b to the x is right here, b to the x equal to m, b to the y equal to n. Very good. Now what is b to the x times b to the y? Well, that is m times n. By the way, this is supposed to be a capital M. It doesn't really matter, but just to be consistent, we want to make sure. Excellent. What is that? Well, that is b to the exponent law says we add the exponent, right? And that is m times n. Let's change that to logarithmic form. So logarithmic form says log of base b, and remember x plus y, that will be the value of the log, and mn, m times n, is the argument. So what was x? What was y? Well, that x was log of m base b, and y was log of n base b. Here is your first law for the multiplication. Here is the multiplication law of logs. So let's go through an example. For example, we want to find out the log of 15 base 2 is, and we want to write it as a product or sum of the two logs, or the product of the argument of the log. So we can rewrite it as log of 5 times 3 base 2, like that, which will be equal to log of 5 base 2 plus log of 3 base 2. Okay, we can simply do that. That's not a big deal. So let's go backwards. Suppose I give you this example. Let's call that B. That was A. All right, this time we want to put it into a single log. Notice that the same bases must have same bases. Remember the first expression or equation, we had all same bases. So here we need to have same base. Okay, they are, and now we put them together. So that is actually log of 6 times 1.5 base 3. Okay, and that is log of 9 base 3, and we know what that is. That's just 2. 3 to the exponent 2 equals to 9. Great. So division law is basically the same as the multiplication law. Now remember again, the value of the log expression, that value is actually the exponent. So whenever you do a subtraction of the logs, that's basically you're dividing the expressions. Remember the exponent laws, right? That's the same idea here. So here it is. This is the division law, and we can apply that. The proof will be the same proof as almost the same proof. It is the same. Instead of a multiplication, you're doing a division of the. So right here we multiply the bx and by. You divide them, and you go through the same thing. This becomes x minus y, the expression, the value of the log, and then you becomes a subtraction. So, and here it is. This is the second law, division law, which is very useful. And let's do a couple of examples. So here it is. We want to simplify this expression. This is 50. So here it is. We write log of 50 divided by 0.4 base 5. Okay. And now once we have that, what is log of 50 divided by 0.4? That's 125. Is 125. So log of 125 base 5, and that is 3. Excellent. So the third one, power law, same as power law for the exponents, same idea here. Okay, so here is the law, and we talked about that actually in last section. So you just bring the n to the front. That's what you will do. So here it is. Then you bring n to the front, and since once you bring that into the front, becomes n times log of x base b. Okay, and then of course base cannot be a 0, has to be greater than 0, and cannot be 1. Let me give you an example. All right, log of 7 squared base 7, what is that equal to? Based on the power law, we're going to bring the 2 to the front. Okay, so that 2 is going to come to the front, so it becomes 2 times log of 7 base 7, but we know that log of 7 base 7, that is 1. So 2 times 1 is 2. Great. Okay, let's look at this one, and we're going to incorporate the calculator use as well, but let's simplify it as much as we can. So we're going to go through. The first thing you have to do, you have to change whatever format you see into the exponential form, because that's the power rule, right? N is a power exponent, right? So we've got to deal with that. So let's go through and use what we know of. So that is 7 to the exponent of third, because the cube root of 7 is written as 7 to the exponent of third. So now what are we going to do? That becomes 1/3 to the front log of 7 base 2. Great. So that's great. Now we're going to use the law of interchanging the bases. So now base 2 becomes base 10, so that we can use our calculator. Most calculators computing log values are on base 10. So that's what we need to do. So let's go to the calculator. So here all we have to do is 1/3, and then in our calculator we do log of 7 divided by log of 2. Whatever we get, we multiply it by 1/3. So here's the calculator. We're going to go in my calculator, I punch in 7 first, then I do log, so I get that value, divided by, and then the next piece is that I need to punch in the log of 2. So 2 log, I get that, and that's a division. I want to know what that is, equals to, and that's 2.8073. Whatever I get, I have to multiply 1/3 or divide it by 3, and that is 0.935. Okay, 0.9358. So that is the final answer. So I want to repeat that you do need to remember changing the radical form to the exponential form. So if you have a cube root of x, that's x to the exponent of a third. Okay, so remember the index is the denominator of the rational exponent, and then the inside, or the exponent of x, or it could be outside the entire thing, that is the numerator of the rational exponent. You need to be very good at manipulating anything with the exponential and the radicals quickly enough, okay, for the log, and that's how you do it. So for this section, what did we cover? We covered multiplication law, which is right here, okay. Then we covered the division law, which is right there, okay. And then we did the power law, which is right there. But within the power law, some textbooks, they use another law called the root law. I disagree. That's just power law, extension of power law, and that means that if you have a square root as an argument, an argument of log, then you have to bring that exponent to the front, which is part of the power law anyways. So those are the 3 major laws, plus the 3 other laws at the beginning, the last section that we talked about. You need to know all of those to be able to manipulate and evaluate logarithmic expressions, and of course solving equations.